everyone. So today we'll be dealing with physics questions from NEET paper 2021. The first question is from the chapter electromagnetic induction. Okay. And the question is, an inductor of inductance L, a capacitor of capacitance C, and a resistor of resistance R are connected in series to an AC source of potential difference V volts as shown in this figure. Okay. The potential difference across L, C and R is 40 volt, 10 volt and 40 volt respectively. That means this is for L, this is for C and this is for R. Okay. Now the amplitude of current flowing through LCR, this will be LCR, please ignore the misprint. LCR series circuit is 10 root 2 ampere. Okay. That means I naught is given as 10 root 2 ampere. Okay. So what will be the value of I RMS here? RMS current is given by I naught by root 2, right? So it will be 10 ampere only. Okay. So here we have to consider the RMS current. Okay. Now the impedance of the circuit is, so here these things are repeated, ignore these things. We just have to find out the impedance of the circuit. Okay. Impedance, what is impedance? It is the effective resistance. Okay. And it is given as Z, whose formula is VRMS, that is RMS voltage or RMS potential difference, divided by RMS current. Okay. So here we have this RMS current as 10 ampere and we have to find out the RMS potential difference, right? So what will be the value of VRMS? It is given as VR square plus VL minus VC whole square. Okay, that means potential difference across R, potential difference across L and potential difference across C. So we have these values. What is the value of VR? It is 40 volt right here. So 40 square plus what is the value for VL? It is again 40 here. So 40 minus VC is your 10, right? So 10 whole square. Now if we calculate this, we will get the value 50 volt. Okay. So now we have the VRMS and we have the IRMS as well. So impedance can be obtained as VRMS divided by IRMS. So it will be VRMS is 50 volt and IRMS is your 10 ampere. So what will we get? 5. Okay. And the unit will be ohm for impedance. So the correct answer will be 5 ohm. That is option D will be your correct answer. Now question number 2 is from the chapter Ray Optics and Optical Instruments, class 12. And the question is, find the value of angle of emergence from the prism. Refractive index of the glass is root 3. So here is your figure. Let's suppose this is point A, this is point B and this is point C. So here you can see angle B is 90 degree. This indicates 90 degree, right? This is your 60 degree. So what will be the value of angle A? We know that the sum of all the angles in a triangle is equal to 180 degree, right? Therefore, angle A plus angle B, that is 90 degree, plus angle C, that is 60 degree, will be equal to 180 degree. Okay. And the sum of 90 degree and 60 degree will be 150 degree. Therefore, angle A will come out to be 180 degree minus 150 degree, that is equal to 30 degree. Okay. So now we know that angle A is equal to 30 degree. So let's draw this figure again in order to understand the process well. And please ignore the irregular line. This is point A, this is point B and this is point C. Okay. So here it is your 30 degree angle. Okay. Now what else is given? An incident ray falls on the surface AC making an angle 90 degree. That means it falls normally. So we can say that the incident ray and the normal to the surface are coinciding with each other. Okay. Therefore, angle of incidence will be equal to 0 degree. Okay. At this surface, it will undergo the first refraction. Okay. So, sorry, please ignore this irregular line. This will be a straight line here. Okay. So, here it will be your R1. Okay. So, R1 will also be equal to 0 degree. Okay. And at this point, at this surface, this is your normal. So it is making an angle R2. It is your second refraction. Okay. So R2 is unknown, and here it will move away from the normal. Okay. So this is your emergent ray and this is your angle of emergence. Okay. This is emergent ray. Okay. So first we'll find out the value of R2 and then we'll find out the value of angle of emergence. Okay. So if you know the property of a prism, you would know that angle of the prism, that is angle A here. Why? Because the rays are passing through two surfaces, AC and AB. So the angle between AC and AB is angle A, that is 30 degree. Okay. Will be equal to R1 plus R2. So here R1 is 0 plus R2 is unknown. Okay. So we'll find out the value of R2 here. R2 will be 30 degree minus 0 degree and it will come out to be 30 degree. So R2 is also 30 degree here. Okay. Understood till now? Now, in order to find out the angle of emergence, we'll use the Snell's law. Let's see what is Snell's law. It says that N1 sine theta 1 is equal to N2 sine theta 2. Here what is N1? N1 is the refractive index of first medium. So here we have to focus on the portion, that is this portion, okay, that I am like surrounding. Okay, so this portion. So here you can see that the ray is coming from the first medium, that is glass, into the second medium, that is air. Okay, so refractive index of the glass will be your N1 and it is given as √3, isn't it? And refractive index of the air, that is N2, will be 1. Okay, now here sine theta 1, theta 1 is your R2. Okay, that is equal to 30 degree and theta 2 is angle of emergence. Okay, that means sine E. Now we have to calculate this. Okay, so √3 into sine 30 is, the value of sine 30 is half, will be equal to 1 into sine E. That means simply we can write sine E. Okay, that means √3 by 2 is equal to sine E. So what value of E will give √3 by 2? It will be 60 degree. Okay, because sine 60 degree is equal to √3 by 2. Therefore, the angle of emergence has to be 60 degree. Okay, so option A will be your correct option. Okay. Now question number 3 is from the chapter Electric Charges and Fields, class 12, and the question is, a dipole is placed in an electric field as shown. What is a dipole? It consists of two equal and opposite charges separated by a certain distance. Okay, so we have to tell in which direction will it move. First of all, focus on this side. Can you see that the electric field lines are very close here? So we can say that on the left hand side the electric field lines are closer, therefore the electric field strength will be more, whereas on the right hand side the electric field lines are away from each other, therefore the electric field strength will be lower. That means from left side to the right side the electric field strength is decreasing. Now since the electric field strength is decreasing, its potential energy will also decrease. Okay, and the net force will act on the dipole towards the right side. Okay, so it will move from left side to the right side. So which option will be correct? Option B. Okay, it will move towards the right side. Why? Because its potential energy will decrease. Okay, so this is your correct answer. Moving to question number 4, it is from the chapter Electrostatic Potential and Capacitance. And the question is, a capacitor of capacitance C is connected across an AC source of voltage V given by V0 sine omega t. Then the displacement current between the plates of the capacitor would be given by, and here are the options. We have to find out the correct one. So let's begin with the simplest equation that we know. Q, that is charge, is equal to the product of capacitance C and voltage V. Okay, now if we differentiate both sides of the equation, we will get dq by dt equals to C, because this is constant. So we'll write it first and then dv by dt. Okay, what does dq by dt represent? It represents the rate of flow of charge, that means current. Okay, so we can write here id, that means displacement current, is equal to C, and differentiation of V. What is V here? V naught sine omega t. That means we have to differentiate V naught sine omega t. Now if we know the basic of differentiation, you would know that it will come out to be C is here first of all. Then it will come out to be V naught omega cos omega t. Okay, so let's change the positions of omega and C. Let's write down the V naught first and then omega and then C and then cos omega t. Okay, we are just changing the position, otherwise the value will be same, right? So which of the options correctly fit this? First one here, this is your omega. Okay, this is not epsilon, this is omega. So it will be omega V naught omega cos omega t, and option A will be the correct one. Question number 5 is from the chapter Moving Charges and Magnetism, class 12, and the question is, a thick current carrying cable of radius capital R carries current I uniformly distributed across its cross section. The variation of magnetic field due to the cable at a distance small r from the axis of the cable is represented by. So here we have a current carrying conductor which is cylindrical in shape. Why? Because the shape of a wire or cable is cylindrical, right? So according to the question, the radius of this cable is capital R, and we have to find out the variation of magnetic field at a distance small r from the axis of the cable. So this distance small r can be somewhere inside the cable and it can be somewhere outside the cable, right? So magnetic field will vary at both the places and we'll see how it varies. Okay, so first we'll see what is the magnitude of magnetic field inside the current carrying conductor, that is cylindrical in shape. Okay, it is only for cylindrical container. So it is given by the formula B, that is magnetic field equals to mu naught I, where mu naught is your constant, I is your current, divided by 2 pi r square, here r, capital R is your radius, into small r, that is the distance inside this conductor. Okay. Now here you can see that magnetic field is directly proportional to small r, isn't it? On the other hand, if we try to find out the magnetic field outside the conductor, then it is given by the formula B equals to mu naught I divided by 2 pi small r. Okay, so here what is the relation between magnetic field and small r? It is inversely proportional to r. Okay, so the graph inside and outside the conductor will vary. So inside the conductor, suppose this is your point R, that is the radius. Okay, so from center till radius it will be a straight line because it is directly proportional to the distance, whereas after this R, that means outside the conductor, it is inversely proportional, so it will be a hyperbolic. Okay, so which option is the correct one? Option C. Now question number 6 is from the chapter Ray Optics, class 12, and the question is, a convex lens A of focal length 20 cm and a concave lens B of focal length 5 cm are kept along the same axis with a distance d between them. So let's first draw these lenses. Okay, first one is your convex lens or lens A and the second one is concave lens or lens B, right? Now the distance between these two, suppose this is your optical center of convex and this is of concave, so this distance will be d centimeter, right? And they are located on the same axis. Now what else is given? If a parallel beam of light falls on A, so here let's draw the parallel beam, this. Okay, so what happens when a parallel beam of light gets refracted from the convex lens? It converges at the focus of the convex lens. Okay, so if this converges at this point O, then this should be your focal length of this convex lens. Okay, so this should be your 20 centimeter. That means focal length of A. But it is given that it leaves B as parallel beam. So it says that it will leave B as this. Okay, and when does this happen? when the rays meet virtually at the focus of concave lens. That means this should be your focal length of concave lens, okay, which is equal to 5 centimeter. Now here to here it is D, and from here to here it is 5, and the total is 20. That means D plus 5 is equal to 20 centimeter. Okay. So what will be the value of D? It will be equal to 20 minus 5 centimeter, that is 15 centimeter. Okay. So option B will be your correct answer here. Got it? Alright, now let's move to question number 7. It is from the chapter Dual Nature of Radiation and Matter. And the question is, an electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. If m mass is a photoelectron emitted from the surface has de Broglie wavelength lambda d, then we have to find out which is the correct option here. Okay. So let's start with the Einstein's photoelectric equation. So according to the Einstein's photoelectric equation, Hc by lambda is given by phi naught plus k. Phi naught is your work function, which is negligible in this case. So we can say that the work function is 0 here. Okay. So we can write that Hc by lambda is simply equal to k, that is maximum kinetic energy. Also, we know that the formula of kinetic energy can be written in terms of momentum as p square by 2m, where p is your momentum and m is the mass. Okay. So we can equate these two, Hc by lambda and p square by 2m, because both are equal to kinetic energy, maximum kinetic energy. Okay. So let's write it down. Hc by lambda is equal to p square by 2m. Okay. So p square will be equal to 2mhc by lambda, and what will be the value of p? It will be the root of 2m hc by lambda. Okay. So we have to use this value of P in the formula of de Broglie wavelength. Okay. So what is the de Broglie wavelength? It is lambda d, and it is equal to h by p, where h is the Planck's constant and p is the momentum. So let's write the h as it is, and in place of p we can put this value, right? So we can put 2mhc by lambda. Okay. So if we get the squares on both sides, we will get lambda d square equals to h square by, here root will be removed, 2m hc divided by lambda. So lambda will move up. Okay. One h will be cancelled here. What will be left? Lambda d square equals to h lambda by 2mc. Okay. So we have to find out the value of lambda here. See, you will see we have to find out the lambda. So lambda will be equal to lambda d square into 2mc by h, right? It can also be written as this 2mc by h first, and then we can write the lambda d square. So which of the options fit this? Option C, isn't it? So this will be your correct answer. Let's come to question number 8. It is from the chapter Current Electricity, and the question is, column 1 gives the certain physical terms associated with the flow of current through a metallic conductor, and column 2 gives some mathematical relations involving electrical conductivities. Then match column 1 and column 2 with appropriate relations. So the first one is drift velocity. Okay, so let's start with the very basic equation. We know that force is equal to mass into acceleration. Okay, so what will be the acceleration here? It will be equal to force divided by mass, and we know that force can be written as the product of small e and capital E, where small e is the electronic charge, that means charge on each electron, and capital E is the electric field. Okay, so the expression for acceleration can be written like this, and the average velocity due to this acceleration, that means drift velocity, will be equal to acceleration into relaxation time. Okay, This is the time between two successive collisions. So in place of A, we can write this equation. So small e into capital E by m into this relaxation time. So this one, that means option R, correctly matches the A, that means drift velocity. Okay. Now the second one is electrical resistivity. Okay. So how to find this electrical resistivity? Let's start with another basic equation. We know that the current density, let's write it down. Current density, that means J, okay, is equal to conductivity into electric field. Okay, this is your electrical conductivity. Also, we know that conductivity is inversely proportional to, is equal to inverse of resistivity. Okay, so in place of conductivity we can write 1 by resistivity, isn't it, into electric field. So what will be the value of this resistivity? It will come out to be E divided by J, that means E electric field divided by current density. So which of these options has this expression? This one, right? So the correct match for B is S. Okay, now come to the third one, that means relaxation period. So how to find this? We'll start with the expression for resistivity here. Okay, resistivity can be written as electric field divided by NEVD, where N is the number of electrons, E is the charge on each electron, and VD is the drift velocity. Okay, so what will be the value of drift velocity here? It will be equal to E divided by N E into rho. Okay. Also, we had found out that the VD can be written like this in the first one. So in place of VD, we can also write small e into capital E by M into tau. And this side we have this expression. So let's write it down. E divided by N E into rho. So E will be cancelled on both sides. Okay. So what will be the value of this tau? That means relaxation time. It will be equal to M divided by Ne square rho. Okay. Let's find this expression in the given options. First one, right? So P is the correct match for C. Okay. And we have only the last one now. That means current density. So current density, see current, what is current density? That means current flowing per unit area. Okay. It is represented by the letter J. Okay. So in place of current, we can write, we know that the current is equal to what? NEAVD. N is the number of electrons, E is the charge on each electron, A is the area, and VD is the drift velocity. And if we divide it by area, then we will get NEVD only. So this is the expression for current density. So Q is the correct match for D. So which of the given options has these matches? Option number A, right? So this will be your correct option. Question number 9 is from the chapter Nuclei, and the question is a radioactive nucleus X with mass number A and atomic number Z. Just remember that mass number is written as top. So this is your mass number and atomic number is represented at the bottom. So this is your atomic number. Okay. Now let's continue the question. It undergoes spontaneous decay in the sequence, this one, where Z is the atomic number of the element X, we have seen. So the possible decay particles in the sequence are. So it's very easy. Just write down the sequence first. X leads to the formation of B, then it further leads to the formation of C, and then lastly D is formed. Okay. Mass number of X is A and the atomic number of X is Z. In the next step, the atomic number of B is Z minus 1. That means the atomic number has decreased by 1. Okay. And in the next step, Z minus 3 is the atomic number of C. That means the atomic number has further decreased by 2. Okay. And in the last step, it becomes Z minus 2. That means from Z minus 3 to Z minus 2 means what? The atomic number has increased by 1. So let's write plus 1 here. Okay. So you just have to remember under what conditions the atomic number varies like this. Okay, so just remember that in case of beta plus decay, the atomic number decreases by 1. Okay, so beta plus decay has taken place in the first step. In the second step, alpha decay has taken place, because in case of alpha decay, what happens? The atomic number is decreased by 2. And in the last step, beta minus decay has taken place, because in case of beta minus decay, the atomic number increases by 1. Okay, so out of the given options, which option has this sequence, beta plus, alpha and beta minus? It is option C. So option C will be your correct answer here. Question number 10 is from the chapter Current Electricity, and the question is the effective resistance of a parallel connection that consists of 4 wires of equal length, equal area of cross section and same material. That means they have the same resistance. Okay, and the effective resistance is 0.25 ohm. Then what will be the effective resistance if they are connected in series? So first, let's see if they are connected in parallel. Then that means they are connected like this. This is your R1, this is your R2, this is R3, and this is R4. Then they will be connected like this at a common point. Okay, now here we have equal length, equal area of cross section and same material. That means all the resistances, individual resistances of each wire will be same. Okay, and we find the effective resistance in case of parallel combination using this formula. 1 by Rp, that means effective resistance in parallel, is equal to the sum of inverse of individual resistances. So here all are same, so 1 by R plus 1 by R plus 1 by R plus 1 by R, that is equal to 4 by R, isn't it? So what will be the value of effective resistance? That means Rp, it will be equal to R divided by 4. And here we are given the value of Rp as 0.25 ohm. Okay, that means 0.25 ohm is equal to R divided by 4. So what will be the value of R? It will be equal to 0.25 ohm into 4. That means we will get 1 ohm. Okay, so each wire has a resistance of 1 ohm. Now in case they are connected in series like this, then what will be the effective resistance? R series will be equal to R1 plus R2 plus R3 plus R4, and here all are same. That means 1 ohm plus 1 ohm plus 1 ohm plus 1 ohm, that will be equal to 4 ohm. Okay, so the answer will be 4 ohm. That means option D will be the correct answer here. Okay, so question number 11 is from the chapter Motion in a Straight Line, and the question is a particle is released from height s from the surface of the earth. At a certain height, its kinetic energy is 3 times its potential energy. Then the height from the surface of the earth and the speed of the particle at that instant are respectively. So suppose this is your surface, then from this height s, the particle has been released, right? Then on coming down at a certain height h, its kinetic energy becomes 3 times the potential energy, isn't it? Now, we know that the total energy will remain conserved. Okay, so let's find out the total energy at point S or at height S. It will be equal to what? Kinetic energy plus potential energy, right? And kinetic energy at this point is 0. So potential energy, that is mg into total height is s, so the total energy will be equal to mgs at this point, right? Now if we find out the total energy at height h, then again it will be equal to kinetic energy plus potential energy. Okay, at this point kinetic energy is not 0, but it is given that it is 3 times its potential energy, so it is 3 times u. Okay, and the sum of 3u plus u will be 4u, that means 4 times the potential energy. What is the expression for potential energy at this point? Mgh. Okay, because h is the height here, so it is equal to 4 mgh, right? Also, we know that the total energy will remain same. That means mgs will be equal to 4 mgh, right? M cancelled, G cancelled. So we get S equals to 4 times H, or you can say H is equal to S divided by 4. So this is the height. Okay. Now we have to find out the speed of the particle at that point. So we will use the formula V square minus U square equals to 2AS. So here U, that is initial speed, is 0. Okay. So V square will be 2 into A. Acceleration here is acceleration due to gravity. So we can write G in place of A. And S is the height or the distance traveled by the particle. Okay. So what distance is traveled? The particle has come till here. Okay. That means the total distance traveled by the particle is S minus H. Okay. This one. So S minus H, okay, we'll get 2 into G into S minus H is what? S divided by 4. Okay. So what do we get? 2G into 3S by 4. So here we can solve like this. 3SG by 2. Okay, so this is the expression for V square. Now if we have to find out the V, we will find out the root of this. So we can write 3gs divided by 2, right? So the velocity or the speed is this and the height was s by 4. So which of the options has these values? Option D, right? Height is h by 4 and velocity or speed or is root under 3gs by 2. So this is your correct answer. Now question number 12 is from the chapter nuclei, and the question is the half-life of a radioactive nuclide is 100 hours. So this is your half-life, that is capital T. Okay. The fraction of original activity that will remain after 150 hours. So this is the small t. Okay. Would be, and here are the options. So we have the half-life, we have the time after which we have to find out the activity. Okay, so we use the formula here for activity as A equals to A naught half to the power given time divided by half-life. Okay, now we have to find out the fraction of original activity. That means we have to find out the fraction A by A naught. Okay. So what will be the value of A by A naught? Half to the power small t divided by capital T. So let's solve this. Half to the power small t is what? 150 and capital T is 100, right? So we will have here half to the power 3 by 2. Okay, and what will be the value? It will come out to be 1 by 2 root 2. So the correct answer will be option B here. Okay. Okay, so question number 13 is from the chapter Thermal Properties of Matter, and the question is a cup of coffee cools from 90 degrees Celsius to 80 degrees Celsius in T minutes when the room temperature is 20 degrees Celsius. So this is your temperature of the surrounding, that is Ts. The time taken by a similar cup of coffee to cool from 80 degrees Celsius to 60 degrees Celsius at the same room temperature, that is 20 degrees Celsius, is. So here we simply have to use a law known as Newton's average law of cooling. Okay. So if you know this law, then you can easily solve this question. Okay. According to the Newton's average law of cooling, T1 minus T2, that means initial temperature minus final temperature divided by time, is equal to a constant K under bracket T1 plus T2 divided by 2 minus Ts, that is temperature of the surrounding. Okay. So here we have two conditions. Under the first condition, we have T1 as 90 degrees Celsius, whereas T2 is 80 degrees Celsius. Okay. So under condition 1, if we put the values into this formula, we'll get 90 minus 80 divided by time t equals to constant K under bracket 90 plus 80 divided by 2 minus temperature of the surrounding is 20 degrees Celsius, right? Whereas under condition 2, T1 is 80 degrees Celsius and T2 is 60 degrees Celsius. So we'll write 80 minus 60 divided by T dash. Here time will be T dash, okay, equals to K constant, then 80 plus 60 divided by 2 minus temperature of the surrounding is same here also, so 20, okay. So let's solve this. 90 minus 80 will be 10, so 10 divided by T equals to, here we'll get, if we solve this we'll get 65, so we'll have 65K, okay. On the other hand, here we'll get 80 minus 60, that is 20 divided by T equals to, on solving this we'll get 50, so 50K, okay. So what will be the value of T here? It will be equal to 10 divided by 65K, and here T dash will be equal to 20 divided by 50K, right? Now we have to find out the T dash, okay, that means time in the second condition, okay. So if we divide the second equation, suppose this is your first equation, this is your second equation, and on dividing the second equation by first equation, we'll get T dash by T equals to 20 divided by 50K into 65K divided by 10, okay. So we'll get here T dash by T equals to 13 by 5, okay. So what will be the value of T dash? It will be 13 by 5 into T, okay. So this will be your value. So out of the given options, the correct one will be option B, okay. Alright, now question number 14 is from the chapter Dual Nature of Radiation and Matter. And the question is, the number of photons per second on an average emitted by the source of monochromatic light of wavelength 600 nanometer when it delivers the power of 3.3 into 10 to the power minus 3 watt will be. So we have to find out the number of photons per second, and this is your Planck's constant, okay. So we know that power equals to energy per unit time, right? Also, we know that energy of each photon is given by hc by lambda, right? So it is hc by lambda. Therefore, energy of n number of photons will be n into hc by lambda. So nhc by lambda, right? So here in place of energy, we can write nhc by lambda. Let's write it down, n into h into c by lambda, and t is already here. So let's put t also. Now what we have to find? Number of photons per unit time, that is number of photons per second, that is n by t. Okay, so what will be the value of n by t? It will be equal to power into lambda divided by h into c, isn't it? Now let's put the values of power, lambda, h and c. Power is given as 3.3 into 10 to the power minus 3. Lambda is also given as 600 nanometer. So we can write 600 into 10 to the power minus 9 meter. Okay. Divided by Planck's constant is also given as, and you can remember the value of Planck's constant as 6.6 into 10 to the power minus 34 into c is the speed of light. So it is 3 into 10 to the power 8. So if you solve this, you will get 10 to the power 16. Okay. So the correct answer will be 10 to the power 16. That is option C will be the correct answer here. Now question number 15 is from the chapter Oscillation, and the question says a body is executing simple harmonic motion, that is SHM, with frequency n, then the frequency of its potential energy is, options are n, 2n, 3n and 4n. So here you can simply remember that whenever the frequency of an SHM is n, then the frequency of its potential energy will become doubled. That means it will become 2n. Okay. But let's see how to solve this. You might be knowing that the displacement x in case of simple harmonic motion is given as a sine omega t. Okay. Also, we know that omega is equal to 2 pi by t, where t is the time, or it can also be written as 2 pi into n, where n is the frequency, and frequency is inverse of t. Okay, so here in place of omega we can write 2 pi n, isn't it? So we'll get 2 pi n into t. Okay, now what will be the potential energy? Potential energy U is given by the equation half k x square. Okay, so let's put the value of x as a sine 2 pi n into t. Okay, half k, and we have to write x square, so we'll write a square sine square 2 pi n into t, right? Now here we have to use a formula from trigonometry that says sine square theta is equal to 1 minus cos 2 theta divided by 2. Okay, here theta is what? 2 pi n into t. Okay, so this is your sine square theta. In place of this we'll put this value. So we'll write half k a square, and under bracket we'll write 1 minus cos 2 theta. That means it will become 2 times, right? So we can write it like this: 2 pi 2n t divided by 2. Okay, so here can you see everything is okay, but this frequency is doubled. It has become 2 times. Okay, so we can say that the frequency of its potential energy will become doubled. So option B will be the correct option. Now question number 16 is from the chapter Magnetism and Matter, and the question is: an infinitely long straight conductor carries a current of 5 ampere as shown. So this is the current. An electron is moving with a speed of 10 to the power 5 meter per second. So this is the speed of the electron, and it is moving parallel to the conductor. The perpendicular distance between the electron and the conductor is 20 centimeter at an instant. So this is the perpendicular distance. That means these angles will be 90 degree. So we have to calculate the magnitude of the force experienced by the electron at that instant. Okay. So first of all, let's start with the magnetic field that will be experienced by the electron near the long straight conductor, and it is given by the expression mu naught I divided by 2 pi r. We know that mu naught by 4 pi has the value 10 to the power minus 7. Therefore, what will be the value of mu naught? It will be equal to 4 pi into 10 to the power minus 7. So in place of mu naught here, we'll write 4 pi into 10 to the power minus 7 into I, that means current. So current is 5 ampere. So we'll write 5. Then 2 pi here, and r is the perpendicular distance. So this is given as 20 centimeter. So we can write 20 into 10 to the power minus 2 meter. Okay. Now on solving this, we'll get half into 10 to the power minus 5. If you solve this completely, you'll get this value, right? So this will be the value of magnetic field. Now we have to calculate the force. Okay, so we know that vector F, that means vector of force, is equal to Q, that means charge, V cross B. Vector V is your velocity or speed, whereas B is the magnetic field. Okay, so we know that A cross B means what? Magnitude of A into magnitude of B into AB sine theta, right? Here theta is 90 degree. So sine theta will be equal to 1. So here simply we'll write magnitude of A into magnitude of B. Okay, because sine theta, that means sine 90 degree, is 1. So we can write what is Q, that means charge. It is the charge of the electron. So we know that an electron has a charge of 1.6 into 10 to the power minus 19 coulomb. Okay. And then what is the value of speed here? It is 10 to the power 5 meter per second. So 10 to the power 5 into, we calculated B as half into 10 to the power minus 5. So half into 10 to the power minus 5. So here we'll get 0.8 into 10 to the power minus 19 Newton. Okay. So we can also write it like this: 8 into 10 to the power minus 20 Newton. Okay. So out of the given options, we'll get option D as the correct answer here. Okay. Question number 17 is from the chapter Units and Dimensions, and it says if force F, acceleration A and time T are chosen as the fundamental physical quantities, then find the dimensions of energy. So we know that to find the dimension of anything, the most commonly used quantities are mass represented as m, distance that is represented as L, and time that is represented as T. Okay, so what will be the dimension of energy? We know that energy is equal to force into displacement, right? And the dimension of force is mlt minus 2, and the dimension of this distance is, or displacement is, L. So the dimension for energy will be ml2t minus 2. Okay, but according to this question, we have to use force, acceleration and time as the fundamental quantities, not mass, distance and time. Okay, so if this happens, the energy will be proportional to certain power of force. Suppose this is power A. Similarly, let's suppose that the power of acceleration will be B and that of time will be C. Okay, now we have the dimension of energy as ml2t minus 2. Okay, so let's write it down. It will be proportional to a power of force. Force has a dimension mlt minus 2. So it will have the power a. Similarly, acceleration that has the dimension lt minus 2 will have power b, and time will have power c. Now let's compare the left hand side and the right hand side. Okay, on the left hand side m has the power 1, and this side the power is a. That means a is equal to 1. Okay, similarly, what is the power of L on left hand side? It is 2. Okay, and on the right hand side, what is the power of L? It is A here and B this side. That means A plus B is equal to 2. Okay, and we know that A is equal to 1. So 1 plus B equals to 2. Then what will be the value of B? It will be 2 minus 1, that is 1 again. So A is also 1 and B is also 1. Now we have to find out C. So what is the power of time this side? Minus 2. Okay, so this side the total power of T we have to find out. It should also be equal to minus 2. Okay, that means T has the power minus 2 at this place and minus 2b at this place and c here. So the total will be equal to minus 2. That means minus 2a minus 2b plus c will be equal to minus 2. Here if we take out the minus sign outside, then we'll get 2a plus 2b minus c equal to minus 2. So minus minus cancelled. Here the value of A is 1, that means 2 into 1 is 2, plus the value of B is also 1, so 2 into 1 is 2, minus C will be equal to 2. So 4 minus C equals to 2, then the value of C will be 4 minus 2, that is 2. So now we have got the value of A as 1, value of B as 1 and value of C as 2. So we can write that if we use F, A and T, then the powers will be F1, A1 and T2. Okay, so here you can see option B has these powers. So this will be your correct answer. Now question number 18 is from the chapter Kinetic Theory, and here we have to match column 1 with the correct formula in column 2. So this is a simply formula based question. You have to remember these formula. First one is the root mean square speed of gas molecules. That means RMS speed of gas molecules, and it is given by the formula root under 3 RT by M. Here R is the gas constant, T is the absolute temperature, and capital M is the molar mass of the gas molecules, right? Now, the second one is pressure exerted by the ideal gas, and here we use the formula 1 by 3 nmv square, V bar we write. Here N is the number of gas molecules, okay. M is the mass of each molecule, okay, or you can say mass of one molecule, and V is the RMS speed of the gas molecules, Okay. Third one is average kinetic energy of a molecule. So it is given by the formula 3 by 2 kT. Here K is the Boltzmann constant. Okay, Boltzmann constant. Therefore, it is also written as Kb. Okay, and what is the formula to find out Kb? Kb is equal to gas constant divided by Avogadro number. Okay, and the last one is total internal energy. Okay, internal energy of 1 mole of diatomic gas. Okay, so here we use the formula 1 by 2 NFRT. So here also R is the gas constant, T is the temperature, N is what? It is number of moles, right? So here number of moles is given as 1, so N will be equal to 1, and F is the degree of freedom, and for diatomic gas it is 5. Okay, so the total internal energy will become 5 by 2 RT. Okay, so what will be the correct match here? Option C will be the correct answer. Okay. Question number 19 is from the chapter Motion in a Straight Line, and the question is a small block slides down on a smooth inclined plane starting from rest at time t equals to 0. Let Sn be the distance traveled by the block in the time interval t equals to n minus 1 to t equals to n. Then the ratio Sn by Sn plus 1 is. Okay, so by the equation of uniformly accelerated motion, the distance traveled in nth second, that is Sn, is given as u plus a by 2 2n minus 1. Okay, here u is the initial speed, and as you can see here that the block had started from rest, that means its initial speed was 0. Okay, so we can write that Sn is equal to simply a by 2 2n minus 1, right? So what will be the distance travel in n plus 1th second? That means Sn plus 1 will be equal to a by 2, 2, and in place of n we'll write n plus 1, right? Minus 1. Okay. Now we have to find out the ratio of Sn and Sn plus 1. So Sn is this, that means a by 2, 2n minus 1, and Sn plus 1 is this, that means a by 2, 2 n plus 1 minus 1. Okay, so a by 2 will be cancelled. Here we'll get 2n minus 1 divided by 2n plus 2 minus 1. Okay, that is equal to 2n minus 1 by this 2 minus 1 is 1, right? So 2n plus 1. So this is the ratio of Sn and Sn plus 1. So out of the given option, the correct one would be option B. Okay, so this is the correct answer. Question number 20 is from the chapter Nuclei, and the question is a nucleus with mass number 240 breaks into two fragments, each of mass number 120. The binding energy per nucleon of the unfragmented nuclei is 7.6 MeV, while that of the fragments is 8.5 MeV. So the total gain in the binding energy in the process is. So let's write down what is mentioned in the question. First of all, we have a reactant whose mass number is given as 240, right? Whereas its binding energy per nucleon is given as 7.6 MeV. On the other hand, the mass number of the product is 120 for each, and there are two such fragments. So total mass number will be 120 into 2. And the binding energy per nucleon is given as 8.5 MeV, right? So we have to find out the total gain in the binding energy, and the total gain in binding energy is equal to binding energy of the products minus binding energy of the reactants. Okay, and the binding energy of the products is mass number of the product into binding energy per nucleon. That means 120 into 2, that is 240, So 240 into 8.5 minus 240 into 7.6. Okay. So here we'll get 2040 and this side we get 1824 and the unit will be MeV. Okay. So we'll get the answer 216 MeV. So this will be the correct answer. So option D is the correct answer here. Let's proceed to question number 21. It is from the chapter Units and Measurement. And the question is, a screw gauge gives the following readings when used to measure the diameter of a wire. Main scale reading is 0 millimeter. Circular scale reading is 52 divisions. Now given that 1 millimeter on the main scale corresponds to 100 divisions on circular scale, the diameter of the wire from the above data is. So here this 1 millimeter is the pitch of the screw gauge. Okay. And number of circular divisions, that is N, is 100. Okay. So we have, let's write it down. Pitch of the screw gauge is 1 millimeter, whereas number of circular divisions N is 100. Okay. So how do we find the least count? Least count of the main scale is equal to pitch divided by number of divisions on circular scale. Okay. That means 1 divided by 100. So it comes out to be 0.01 millimeter. Now if we have to convert it into centimeter, we'll get 0.001 centimeter, right? Why? Because all the options are given in centimeter, therefore I am converting it into centimeter, right? Now we have to find out the diameter of the wire, and the diameter of the wire is equal to the main scale reading plus the product of circular scale reading and least count. Okay. So the main scale reading is given as 0 millimeter. So it will be 0. Even if you convert it into centimeter, it will remain 0, right? Plus circular scale reading is 52 divisions. So 52 into least count is 0.001 centimeter. 0.001 centimeter. Okay. So we get here 0.052 centimeter as the diameter of the wire. So option D will be the correct option. Okay. Question number 22 is from the chapter Electrostatic Potential and Capacitance, and here we have to find the equivalent capacitance of the combination shown in this figure. Okay. Suppose this is point 1, this is point 2 and this is point 3. Then all the 3 points are at the same potential since they are connected by a conducting wire. Okay. That means that this capacitor is short circuited. Okay. Now we have to find the effective capacitance of these two capacitances, and since they are in parallel combination, we know that the effective capacitance in case of parallel combination is given as the sum of all the capacitances. So here C1 and C2 are same, that is C. So C plus C will be equal to 2C. So option B is the correct answer here. Okay. Now question number 23 is from the chapter Ray Optics and Optical Instruments, and the question is, a lens of large focal length and large aperture is best suited as an objective of an astronomical telescope since. So here are the options, but before we go through the options, just remember two formula. First is the magnifying power of this telescope. Okay, so magnifying power is given as the focal length of the objective divided by focal length of the eyepiece. Okay, that means FO divided by FE. So this shows that the magnifying power is proportional to the focal length of objective lens, right? That means more the focal length, more will be the magnifying power, right? Therefore, we prefer larger focal length. Similarly, the resolution power of the telescope is given as A by 1.22 lambda, where lambda is the wavelength of the light and A is the diameter of the aperture. Okay. So the resolution power is proportional to the diameter of aperture. So more is the diameter of the aperture, or we can say the larger the aperture, more is the resolution power, right? Now come to the options. First one is a large aperture contributes to the quality and visibility of the images. So that is true. We have seen here. Why does this happen? And it ensures better light gathering power. So this is true. Due to this, it contributes to the better quality of visibility of images, right? And option C is a large aperture provides a better resolution. That is also true. So all of these statements are true. That means option D will be your correct answer here. Okay. Now this question is from the chapter Electrostatic Potential and Capacitance, and the question is two charged spherical conductors of radius r1 and r2 are connected by a wire. Then the ratio of surface charge densities of the spheres sigma 1 by sigma 2 is. So here we have two spherical conductors. One has the radius r1 and the second has the radius r2. Okay, and both of them are connected through a wire. Now we have to find out the ratio of surface charge densities in terms of radius. Okay, here you can see all the options are given in terms of radius. So we know that electric field is equal to sigma by epsilon naught for conducting spheres, right? Also we know that potential is equal to E into R, that is electric field into resistance. So electric field is sigma by epsilon naught and R will be written as it is. So this shows that the potential is proportional to sigma and R. Okay, that is, it is proportional to the product of surface charge density and the radius. Now, since these two spheres are connected through the wire, they will have the same potential. Okay, that means V1 will be equal to V2, or we can say sigma 1 R1 will be equal to sigma 2 R2. Okay. Now sigma 1 divided by sigma 2 will become R2 divided by R1. Therefore, the correct option out of the given will be option B. Okay, so this is the correct answer here. Alright, now question number 25 is from the chapter Oscillations, and the question is a spring is stretched by 5 centimeter by a force of 10 Newton. Then the time period of the oscillations when a mass of 2 kg is suspended by it is. So we know that in a spring the force is directly proportional to the displacement x, right? So we can write force equals to k into x, where k is the spring constant. Now here we know the value of force and displacement both. We have to find out the value of spring constant first. So spring constant will be equal to force divided by displacement. Force is given as 10 Newton, right? So we'll write 10 here, and the displacement is given as 5 centimeter. So we can write 5 into 10 to the power minus 2 meter. Okay, so we'll get here 2 into 10 to the power 2 Newton per meter as the spring constant. Okay, so 10 to the power 2 means what? 100, right? So 2 into 100 will be 200 Newton per meter. So this is our spring constant. Now we can find out the time period by its formula. So time period, that is T, is equal to 2 pi root under m by k, where m is the mass that is attached and k is the spring constant. Okay, so this is equal to 2 pi, and root under mass is given as 2 kg, right? So 2 divided by k is 200 here. So 200, that means 2 pi into root under 1 by 100, and 1 by 100 will be equal to 1 by 10. Root under 1 by 100 will be equal to 1 by 10. So 2 pi divided by 10. Okay, so here we'll get the answer 0.628 if you solve this term. Okay, so 0.628 seconds will be the time period. That means which option is correct? Option 4 is or option D is the correct option here. Okay, so question number 26 is from the chapter Moving Charges and Magnetism, and the question is, for a plane electromagnetic wave propagating in x direction, which one of the following combination gives the correct possible directions for electric field and magnetic field respectively? Okay, so we know that three directions are there. Okay, first one is your x direction, second one is your y direction, and the third one is z direction. Okay, now if we represent a wave in its vector form, then it will have the I component when it is moving in x direction. Similarly, it will have j component when it is moving in y direction, and it will have k component when it is moving in z direction. Okay, so here this electromagnetic wave is propagating in x direction, so it should have which component? I component, right? Now, we also know that the direction of propagation of an electromagnetic wave is given as vector E cross vector B. That means the electric field and the magnetic field are perpendicular to each other. Okay. So, let's look at the options to check which one of them is correct. Okay. So, the first one is that electric field is given as vector J cap plus K cap. Okay. Whereas magnetic field is given as again J cap plus K cap. What does this mean? This direction and this direction is same. That means the electric field and magnetic field are in the same direction, so they are parallel to each other. So this is not possible, okay, because they should not be parallel, they should be what? Perpendicular, right? Now we'll check option C and D first because they are wrong answers. Okay, so we'll look at the correct option at last. So option C is vector E is given as J cap plus K cap, and magnetic field, that is B, is given as minus J cap minus K cap. Okay, so you can also write this as minus J cap plus K cap, right? So J cap plus K cap and J cap plus K cap both are same, just minus sign is there. That means they are anti-parallel to each other. Okay, again this is not correct because they don't have to be anti-parallel, they just have to be perpendicular. Okay, and the last one is electric field is given as J cap minus J cap plus K cap, and magnetic field is given as minus J cap plus K cap. Again same to same, that means they are parallel to each other. So this is also not possible. So the only possible answer can be option B. Okay, so you can also find out the cross product here. Vector E is given as what? Minus J cap plus K cap. Okay, and B is given as minus J cap minus K cap. So let's find out the cross product of both. So E cross B in this case will be, we'll make a table here. This is I, this is J, this is K. Okay. Now, here I component in the electric field is what? 0. Okay, no I component is there. J component is minus 1, so we'll write minus 1. K component is 1, so we'll write 1. Okay. Similarly, in magnetic field, the I component is 0, J component is minus 1, and K component is also minus 1. Okay. So let's find out the cross product. Here, I, to find out the I component, we have to hide this column and cross multiply J and K column. So we'll get what? Minus 1 into minus 1 will be plus 1, and minus 1 into 1, that is plus 1. So minus 1. So minus minus plus, it will be 1 plus 1. Okay. Then we have to find out J component. Okay. So J component will be what? We'll hide the column J and will cross multiply I and K. Okay. So since there are two zeros this side, so it will be 0. Okay. Similarly for K component, it will be 0. Okay. So at last we'll get 2I. So can you see that only I component is there? That means the wave is moving in X direction. Okay. So option B will be your correct answer. Okay, so question number 27 is from the chapter Gravitation, and the question is the escape velocity from the Earth's surface is v. Then the escape velocity from the surface of another planet having a radius 4 times that of the Earth and same mass density is. So suppose the radius of the Earth is r, then the radius of another planet will be 4r, okay, because it is 4 times. Also we know that the escape velocity of the Earth is given as root under 2gm divided by r, where g is the gravitational constant, m is the mass of the earth, and r is your radius of the earth. Okay, so here in the question radius is mentioned and density is mentioned, whereas in the formula you don't see any density. Okay, so we'll write mass in terms of volume and density. Okay, we know that mass by volume equals to density. Okay, rho denotes the density, right? So what will be mass? It will be equal to volume into density. And for a sphere, the volume is 4 by 3 pi r cube. So mass will be 4 by 3 pi r cube into density. Okay. So in place of mass, we can write this, isn't it? So let's write it down. Root under 2g by r into 4 by 3 pi r cube into density, that is rho. Okay. Now if we solve this, then 2 into 4 will be 8 pi g r square. Why? Because 1 r will cancel 1 r here. Okay. So r square will be left into density divided by 3 and all will be under the root. Okay. Now here you can see that the escape velocity is proportional to root under r square, that means r. Okay, so the escape velocity is proportional to radius. Now the escape velocity of the earth divided by escape velocity of the planet will be equal to radius of the earth divided by radius of the planet, that is 4 times radius of the earth. Okay, here it was given. So what will be the escape velocity of this planet? It will be equal to 4 into escape velocity of the earth, right? So option D will be the correct answer here. Got it? Alright, now question number 28 is from the chapter Current Electricity. And the question is, in a potentiometer circuit, a cell of EMF 1.5 volt gives balance point at 36 centimeter length of wire. If another cell of EMF 2.5 volt replaces the first cell, then at what length of the wire the balance point occurs? Okay, that means in first case EMF is 1.5 volt. Okay, so we can write that E1 is 1.5 volt, whereas length is given as 36 centimeter. Okay, similarly E2 is given as what? 2.5 volt, and we have to find L2. Okay, it is unknown. So here you should remember that the potential gradient remains constant. Okay, it is equal to E by L. That means E will be proportional to L. So here you can write E1 by E2 is equal to L1 by L2, right? So here E1 is what? 1.5 volt. E2 is what? 2.5 volt. L1 is 36 and L2 is unknown. So L2 will be equal to what? 36 divided by 1.5 into 2.5. Okay, so here we'll get 60 centimeter as answer. So option A will be the correct answer here. Now question number 29 is from the chapter Mechanical Properties of Fluids, and the question is, the velocity of a small ball of mass m and density d when dropped in a container filled with glycerine becomes constant after some time. So velocity becomes constant means acceleration becomes 0, right? Now if the density of the glycerine is d by 2, then the viscous force acting on the ball will be. So here let's see what is given in the question. We have a container that is filled with glycerine. Now a ball is dropped into this container. So this ball will have two types of forces acting on it in the upward direction. First one will be the viscous force or Fv, and one will be the buoyant force or Fb. Okay. Similarly, what force will be acting in the downward direction? It will be the weight of this ball, that is equal to mass into acceleration due to gravity. Okay. So the total force acting in the upward direction will be equal to the total force acting in the downward direction. That means mg will be equal to viscous force plus buoyant force. Okay. And here we have to find out the viscous force. That means Fv. So that will be equal to mg minus Fb. Now here you can see that density is mentioned in the question. So we will write mass in terms of density. You might be knowing that mass by volume is equal to density. So what will be mass? It will be equal to volume into density. Okay. Small d is the density of the ball, as you can see here. Okay. So here we can write in place of m, v, that is volume of the ball, into density of the ball, into g. Okay. minus what will be the Bion force? It will be equal to the volume of the glycerine into density of the glycerine into acceleration due to gravity. So volume of the glycerine will be same as that of the ball, okay, into density of the glycerine is given as d by 2, okay, so into d by 2 into acceleration due to gravity, right? So here we'll get half VdG, okay, and volume into density is what? Mass. So here we can put mass again, so half mg, that means mg by 2. So out of the given options, first one will be the correct one. Got it? Alright, now question number 30 is from the chapter Electrostatic Potential and Capacitance. And the question is, a parallel plate capacitor has a uniform electric field vector E in the space between the plates. If the distance between the plates is small d and the area of each plate is A, then the energy stored in the capacitor is. So here we have a parallel plate capacitor with uniform electric field vector E, right? What is the distance between the two plates? It is equal to small d and the area of each plate is capital A. Okay. Now we have to find out the energy stored in the capacitor, and there is a simple formula for energy stored. It is given as half CV square. Here C is the capacitance and what is V? V is the potential difference. Okay. Now we will write the values of capacitance and potential difference each. So capacitance is given by the formula epsilon naught A by D, where A is the area of each plate and D is the distance between two plates, okay, of the capacitor. So here we can write half into epsilon naught into A by D. And what will we write in place of V square? So V is given as electric field strength into the distance between the two plates. Okay. So E into D. So here we have V square. So we can write E into D square. Okay. So let's solve this. Half epsilon naught A by D into E square into D square. Okay. So one D will be cancelled here. So we will be left with half epsilon naught E square A D. Okay. So which of the given options match with this? It is option C. Okay. So option C will be the correct answer. Now question number 31 is from the chapter Semiconductor Electronics, and the question is, the electron concentration in an N-type semiconductor is the same as hole concentration in P-type semiconductor. An external electric field is applied across each of them, then compare the currents in them. Okay. So we have to compare the currents in N-type semiconductor and P-type semiconductor. Okay. So we know that the majority charge carriers in case of N-type semiconductors are electrons, whereas the majority charge carriers in case of P-type semiconductors are holes. Okay. Also, we know that the amount of current is given by the formula NEAVD, where N is the number of electrons, E is the charge on an electron, E is the area of the conductor, and VD is drift velocity of the charge carriers. Okay. Now, drift velocity can be written as mu into E, where E is the electric field and mu is the mobility of the charge carriers. Okay. So here we can write that the current is equal to NEA mu into E. Okay. So this shows that the current is directly proportional to mu, or the mobility of the charge carriers. Okay. Now, since the effective mass of the electron is smaller than the effective mass of the holes. Okay. So let's write it down. Effective mass of electrons are less than the effective mass of holes. Therefore, the mobility of electrons are more than the mobility of holes. Okay. So the current in case of N-type semiconductor will be more than the current in p-type semiconductor. Okay. Therefore, which option will be correct? It will be option C, that the current in n-type is more than the current in p-type. Okay. Alright, next question is again from the same chapter, Semiconductor Electronics, and it says consider the following statements A and B and identify the correct answer. So the first statement is a Zener diode is connected in reverse bias when used as a voltage regulator. So this is a correct statement. Why? What happens in reverse bias is that after breakdown, the voltage across the Zener diode becomes constant. Okay. So let's write it down. Voltage across Zener diode becomes constant. Okay. Therefore, it acts as a voltage regulator. Now, what is the second statement? It says the potential barrier of PN junction lies between 0.1 volt to 0.3 volt. Okay. So the potential barrier is denoted by what? V naught. Okay. And the potential barrier of germanium is 0.3 volt. Okay. Whereas the potential barrier of silicon is 0.7 volt. So as you can see, it is more than 0.3 volt. But here it says that it can be only 0.1 to 0.3. So this is not a correct statement. Okay. So only statement A is correct and B is incorrect. So option C will be the correct answer here. Now question number 33 is from the chapter Electrostatic Potential and Capacitance, and the question is polar molecules are the molecules, option A, having zero dipole moment. So this is incorrect because they have certain value of dipole moment. Okay. Option B is acquire a dipole moment only in the presence of electric field due to the displacement of charges. So this is also incorrect. And option C is acquire a dipole moment only when magnetic field is absent. So this is also an incorrect option. So according to these two options B and C, the dipole moment in a polar molecule are temporary, right? But this is not the case because they have permanent electric dipole moment. Therefore, option D will be correct. Okay. So let's see how the charges in a polar molecule are arranged. Here the center of positive charge and center of negative charge are separated by a certain distance. Okay. Or we can say that the center of positive charge does not coincide with the center of negative charge. Okay. Therefore, they have permanent electric dipole moment. So I hope you understood this. Now question number 34 is from the topic dimensions, and the question is if E and G respectively denote energy and gravitational constant, then E divided by G has the dimensions of, and here are the options. Okay. So first of all, we know that what is the formula for force in case of gravitation? It is equal to G into M1 into M2 divided by R square, right? Now, what is the formula for work or energy? Both have same formula, right? So it is given by force into displacement, and displacement is denoted by R. So here we can put the formula of this force. Okay. So if we put force equals to G M1 into M2 divided by R square into this R. Okay. So what will be left? One square will be cancelled. We'll be left with G into M1 into M2 divided by R. Okay. So this will be your energy. Okay. So this will be your energy. Now we have to find out the dimension of E divided by G. So what will be the formula of E divided by G? It will be equal to G into M1 into M2 by R. That is your E, and divided by G, right? So G will be cancelled. What will be left? Only M1 into M2 divided by R. Okay. So the dimension for M1 is M. Again, M2 is also M. And the dimension for R is your L. So it is in division, right? So here if we will write L to the power minus 1. Okay. So what will we get? M square, because 2M are there, and L minus 1. And what is the dimension of T? Nothing. So it will be 0. Okay. So out of the given options, the correct option will be M square L to the power minus 1 and T to the power 0. That is option 1 will be correct. Alright, now question number 35 is from the chapter Work, Energy and Power. And the question is, water falls from a height of 60 meter at the rate of 15 kg per second to operate a turbine. The losses due to frictional force are 10% of the input energy. Then how much power is generated by the turbine? And acceleration due to gravity is to be taken as 10 meter per second square. Okay, so now total power input, that is known as incident power, will be equal to what? Rate of change of energy. Okay, so incident power will be equal to dE by dt. And what will be the energy at this highest point? It will be the potential energy. So we have to find out d into mgh by dt. Also, acceleration due to gravity, that is g, and height will remain constant. So first we'll take these out and then we'll get Tm by dt. So here the value of acceleration due to gravity will be 10 meter per second as given in the question. Height is also given as 60 meter and dm by dt is the rate of mass flow, which is given as 15 kg per second. So here on solving this, we'll get 9,000 and the unit will be watt. So 9,000 watt power is totally created. Okay. Now out of this, 10% is lost due to frictional force. Okay, that means 10% out of 100 is lost. So we can say that how much is left? 90% is left. Okay, to be generated. That means 90% of 9,000 watt will be generated, or you can say 90 by 100 into 9,000 watt is generated. That will be equal to 8100 watt. Okay, so this much power is generated. So out of the given options, option B will be correct, because 81,000 volt will be equal to divided by 1000 kilowatt. Okay, so we'll get 8.1 kilowatt. Okay. Question number 36 is from the chapter Motion in a Plane, and the question is, a car starts from rest, that means initial velocity is 0, and accelerates at 5 meter per second square. So this is the acceleration. At t equals to 4 seconds, a ball is dropped out of a window by a person sitting in the car. Then what is the velocity and acceleration of the ball at t equals to 6 seconds? So let's talk about the car first. What was the initial velocity of the car? It is 0 because it started from rest, right? Now acceleration is given as 5 meter per second square. Then can we find out the velocity at time 4 second? So at t equals to 4 second, the velocity will be given by the formula u plus at, where u is the initial velocity, that is 0 here. Acceleration is given as 5 meter per second square and time is 4 seconds. Okay. So here we'll get 20 and the unit will be meter per second. So the car is moving with the velocity 20 meter per second at t equals to 4 second. Okay. Now come to the second part, that is the ball. Okay, so suppose this is a window. A ball has been dropped from the window after 2 seconds of this point. Okay, that means at t equals to 6 seconds. Okay, or you can say after 2 seconds. So the ball will have the two components of velocity here. Okay, first one will be the horizontal component or Vx, and second component will be the vertical component or Vy. The horizontal velocity will be in the direction of the movement of car. That means it will be same as the velocity of the car, that is 20 meter per second. Okay. Now what will be the vertical component of velocity? We can find it out using the same formula u plus at. So here u will be the initial velocity of the ball, that is 0. Acceleration of the ball will be equal to g, that is acceleration due to gravity. Okay, because the ball is under the free fall. Okay, and time is 2 seconds, because after this point, that is t equals to 4 seconds, after 2 seconds of this time we are calculating the velocity of the ball. Okay, so here 0 plus g is 10 into time is 2. So what will we get? 20 meter per second. Okay, so the horizontal component is 20 meter per second and vertical component is also 20 meter per second. So the net velocity will be the resultant of Vx and Vy. So it will be equal to Vx square plus Vy square, okay, and under root. So here we'll get 20 square plus 20 square, that is equal to 400 plus 400, and here on solving this we'll get 20 root 2 meter per second. So this will be the velocity of the ball at t equals to 6 seconds. Okay, and what will be the acceleration at this point? It will be same as acceleration due to gravity, that is 10 meter per second square. So the correct option will be option D. Okay, here you can see this is the velocity and this is the acceleration, right? Alright, now question number 37 is from the chapter Semiconductor Electronics, and the question is, for the given circuit, the input digital signals are applied at the terminals A, B and C, then what would be the output at terminal Y? So here you can see A, B and C are the input terminals, whereas Y is the output terminal. Also we should be able to identify the symbols. So this is the symbol for AND gate. This is the combination of AND and NOT. This small bubble is the NOT. So this will be NOT AND or NAND in short. Whereas this is the symbol for OR gate. Okay. Now how do we represent AND? We put a dot between the signals. For example, A and B are connected through AND gate. So it can be represented as A dot B. Similarly, B and C are connected through NAND gate. So first we'll write B dot C and then we'll put a bar to represent NOT. Okay, so it will be the representation for NAND gate. Okay, now A dot B and B dot C bar are connected through an OR gate. So the resultant will be A dot B plus B dot C bar. That means plus is used for OR gate. Okay, so this will be the output of this circuit. Now let's have a look at this figure, the upper one. Here you can see that some lines are lower whereas some lines are raised up. Okay, so the lower lines will have the value 0 whereas upper lines will have the value 1. Okay, so let's make a table first to understand this well. First of all, we'll write the time duration. So the time durations are 0 to t1, then t1 to t2, then T2 to T3, T3 to T4, T4 to T5 and then T5 to T6, right? Here we'll write the values of A, B and C separately. Then we'll write the value of A dot B and then B dot C bar and then the final output Y. Okay, that means A dot B plus B dot C bar. Okay, now look at this time duration 0 to t1, that means this portion. Okay, here what is the value of A? The line is lowered, so the value is 0. Okay, here similarly for B it is 0 but for C it is 1. Okay, similarly for t1 to t2, that means this duration, you can see that A is 1, B is 0 and C is 1 again. Okay, for T2 to T3, A is 0, B is 1, then C is 0 again. Similarly, T3 to T4, we have 1, 1 and 0, then 0, 0, 1, then 1, 0, 1. Okay, now we'll write the values of A dot B. What is A dot B? Here, just see, suppose we have to find out the resultant of A dot B, then both A and B should have a value 1, then only the resultant will be 1. Okay, otherwise the resultant will be 0. Got it? So here you can see that A and B, neither A nor B has a 1, so the resultant will be 0. Similarly, here only A has 1, B does not have 1, so it will be 0 again 0, but here both have 1, so the resultant will be 1. Here 0 again, then 0 again. Okay, now for B dot C bar, first we'll find B dot C and then we'll write the opposite of that. Okay, because for bar it will be opposite. So B and C, Here only C has 1, B does not have 1, so it will be 0, but due to bar it will become 1. Okay. Similarly here it will be 0, but the opposite will be 1. 0, but opposite will be 1. Again 1, again 1, again 1. Okay. So as you can see, all the values in B dot C are 1. Now what will be the resultant here? Here these two, A dot B and B dot C bar, are connected through OR. So if either one of them has a 1, then the resultant will be 1. Okay. So here the resultant will be 1, 1, 1, 1, 1, 1. Okay. It will be 0 only when both the signals have the value 0. Okay. So as you can see that for 1 we draw a raised line. Okay. While for 0 we draw a lowered line. But here none has the value 0. So all lines will be raised up. Okay. So the line will be, or the signal will be something like this. Okay. So let's look at the options. Which of the options represent this? It is option C. Okay. So this will be the correct answer here. I hope you understood this. Okay, now question number 38 is from the chapter Laws of Motion, and the question is, a ball of mass 0.15 kg is dropped from a height 10 meter, strikes the ground and rebounds to the same height. Then the magnitude of impulse imparted to the ball is nearly. Okay, so we have mass given as 0.15 kg. Okay, and the height from which the ball has been dropped is 10 meter. And we have to find out the impulse. So what is impulse? It is the change in momentum. Momentum is represented by the letter P. Okay, so we can write it as final momentum minus initial momentum, right? And what is momentum? It is nothing but the product of mass and velocity. So in place of final momentum we can write mass into final velocity, and in place of initial momentum we can write mass into initial velocity. Okay, so let's take the mass common, and under bracket we will have final velocity minus initial velocity. Now here initial velocity is the velocity of the ball before collision, whereas the final velocity is the velocity of the ball after collision. Okay. So we know the value of mass because it is given as 0.15 kg. But we don't know the value of velocity. So first we'll try to find it out. Okay. So the velocity before collision, that is initial velocity, will be equal to root under 2gh. Here we will have 2 into g is acceleration due to gravity. So it is given as 10 meter per second square, and height is given as 10 meter. So on solving this we get 10 root 2 and the unit is meter per second. Okay. Now we have to find out the velocity after collision. So as mentioned in the question, the ball rebounds to the same height. What does this mean? That the ball moves back or it rebounds with the same velocity. Okay. So final velocity is equal to initial velocity. That means it will also be equal to 10 root 2 meter per second. But direction is opposite, right? If one will be in positive, then the other will be in negative. So let's take any one of them in positive. So I'm taking final velocity as positive and initial velocity as negative. You can take the final as negative as well. Okay. So here we can put the value of final velocity. It is 10 root 2 minus initial is what? Minus 10 root 2. Okay. And the unit is meter per second and unit of mass is kg, right? So here if we will have 0.15 in kg into, on solving this we get 28.28 meter per second. Okay, so on multiplying this and this we get 4.2 kg meter per second. Okay, now if we would have taken final velocity as negative, then the answer would be negative, but sign doesn't matter here, only the magnitude matters. Okay, so it is 4.2 kg meter per second. So option B will be the correct answer here. Got it? Alright, now question number 39 is from the chapter System of Particles and Rotational Motion. And the question is, a uniform rod of length 200 centimeter and mass 500 gram is balanced on a wedge placed at 40 centimeter mark. A mass of 2 kg is suspended from the rod at 20 centimeter and another unknown mass m is suspended from the rod at 160 centimeter mark as shown in the figure. Then find the value of m such that the rod is in equilibrium. Okay. So let's draw this figure again. We have a rod whose length is 200 centimeter and mass is given as 500 grams, so we can write it as 0.5 kg, right? Now this 0.5 kg mass of the rod will be concentrated at the center of mass, that will be at the center of the rod here. So this will be at 100 centimeter, that means half the length of the rod. Okay, so this is one of the mass on this rod. Then a mass 2 kg is suspended at which point? 20 centimeter, whereas an unknown mass m is suspended at 160 centimeter. And where is the wedge located? It is located at 40 centimeter. So suppose this is the wedge, okay, at 40 centimeter, and this wedge is the balancing point of this rod. Okay. Now, according to this question, the rod is in equilibrium. So what will happen at equilibrium? The total torque on the left side of the wedge will be equal to the total torque on the right side of the wedge. That means the total torque will be balanced. Okay. So suppose the torque due to mass 2 kg is torque 1. The torque due to mass 0.5 kg is torque 2. And the torque due to mass m kg is torque 3. Then at equilibrium, torque 1 will be equal to torque 2 plus torque 3. Okay. And what is torque? It is given by the formula vector F cross vector R, where vector F is the force and R is the distance from the balancing point, that is distance from the wedge. Okay. So it will be equal to FR sine theta, and theta will be 90 degree because rod is in this direction, mass is in this direction, so the angle is 90 degree. So sine theta will be equal to 1. So we can simply write F into R. Okay. F will be equal to the weight that is being suspended. So for the first one, the force or weight is 2 kg, whereas the distance from the wedge is 20 centimeter. Okay. This distance is 20 centimeter. Similarly, for torque 2, the force is 0.5 kg, whereas the distance from the wedge is 60 centimeter because the wedge is at 40 centimeter and this mass is at 100 centimeter. So the distance from the wedge is 60 centimeter. Got it? Now for torque 3, the force is weight m and the distance from the wedge is 120 centimeter. Okay. Because the wedge is at 40 centimeter and this is at 160. So the distance will be 160 minus 40, that is 120. Now we'll solve this. 2 into 20 will be 40, 0.5 into 60 will be 30 and this will be equal to 120 m. Okay. So 40 minus 30 will be 10, that will be equal to 120 m. So what will be the value of m? It will be equal to 10 divided by 120, that means it will be equal to 1 by 12 kg. Okay. So out of the given options, option D will be the correct answer here. Now question number 40 is from the chapter Ray Optics and Optical Instruments, and the question is, a point object is placed at a distance of 60 centimeter from a convex lens of focal length 30 centimeter. If a plane mirror were put perpendicular to the principal axis of the lens and at a distance of 40 centimeter from it, then the final image would be formed at a distance of, okay, so this is the position of object. Okay, so this is at 60 centimeter from the convex lens, and just remember that the object distance in case of convex lens is always in negative, so u will be equal to minus 60 centimeter. Okay, whereas focal length is written in positive, so it is equal to 30 centimeter, and we have to find out the distance of image from the lens. So we'll use the lens formula here. Okay, so 1 by v minus 1 by u will be equal to 1 by f. Okay, 1 by v will be equal to 1 by f plus 1 by u, or you can say u into f and here u plus f. So this is for 1 by v. What will be v? It will be equal to u into f divided by u plus f. Okay, so the u is minus 60 F is 30, again minus 60 plus 30. So on solving this, we'll get 60 centimeter. That means the image is formed at a distance of 60 centimeter from the lens, but at 40 centimeter there is a mirror. So how much distance from the mirror this image is formed? 20 centimeter, right? 40 plus 20, 60. But this real image by the convex lens will act as a virtual object for this mirror. So this mirror will form the image of this object in front of it at a distance of 20 centimeter. Okay. So it is also 20 centimeter from the lens, because this is whole distance is 40 centimeter. So 20 and 20. Okay. So this is for the first refraction. Now for the second refraction, let's make a fresh diagram here. At a distance of 20 centimeter from the lens, the object is present, because this will act as the object in case of second refraction. Okay. So U is 20 centimeter and we have to write in negative. So it will be minus 20 centimeter. Okay. And focal length will remain same. So it will be 30 centimeter. Now we have to find out the next image formed. Okay, so again we'll use the lens formula here. Okay, but let's see the diagram first. If here is the object, rays will go like this and then they will move like this, but they will move back and meet virtually behind the mirror. Okay, suppose this is your mirror. So we have to find out the distance at which it will be formed. So again we'll use the lens formula. That means 1 by V2 minus 1 by U2 equals to 1 by F. So again V2 will be equal to what? U2 into F divided by U2 plus F. Okay. So let's put the values. V2 equals to, U2 is minus 20. So minus 20 into 30 divided by minus 20 plus 30. Okay. So it will come out to be minus 60. That means this distance, this image will be formed at a distance of 60 centimeter from the lens. And at 40 centimeter there is a mirror. So what distance from the mirror? 20 centimeter. Okay. So 20 centimeter from the mirror, and it will be made virtually. So option D will be correct, that it is produced 20 centimeter from the plane mirror and it would be a virtual image. Got it? Now question number 41 is from the chapter Alternating Current, and the question is, a step down transformer connected to an AC main supply of 220 volt is made to operate at 11 volt a 44 watt lamp. Then ignoring the power losses in the transformer, what is the current in the primary circuit? Okay, so we know that in an ideal transformer, what happens? The total input power is equal to the total output power. Okay, so we can write it like this: power input is equal to power output. So power is the product of voltage and current. So here we can write that the product of voltage and current in the primary circuit is equal to the product of voltage and current in the secondary circuit. Okay, and the voltage in primary circuit is given as 220 volt. Okay, so here we can write 220 into current is unknown, so we'll write IP here, and here 44 watt is the total output power. Okay, so here it is the product of voltage and current in the secondary circuit, so we can write 44 watt here. So we can find out the value of current in the primary circuit as 44 divided by 220. So here we'll get 0.2 ampere, and therefore option A will be the correct answer. Now question number 42 is from the chapter Current Electricity, and the question is, three resistors having resistances R1, R2 and R3 are connected as shown in the given circuit. The ratio I3 to I1 of currents in terms of resistances used in the circuit is, so here you can see that R2 and R3 are in parallel combination. Okay, and we know that in case of parallel combination, the potential difference across the resistances is same. Okay, so we can write here that the potential difference across R2 is equal to the potential difference across R3. So potential is equal to what? The product of current and resistance. So here V2 will be equal to I2 into R2, and that will be equal to I3 into R3. Okay. So what will be the value of I2? It will be equal to I3 into R3 divided by R2, and this is the equation 1. Now, as per the Kirchhoff's law, what happens? The total current coming towards a junction is equal to the total current leaving that junction. So suppose this is the junction in the figure. Look at this figure. Current I1 is coming towards this junction, whereas I2 and I3 are leaving this junction, right? So I1 will be equal to the sum of I2 and I3. Here, in place of I2, we can write this one. That means I3 R3 divided by R2 plus I3. Okay. Now if we take I3 out of the bracket, then we'll get under bracket R3 by R2 plus 1. Right. What will be the value of I1 by I3? It will be equal to R3 by R2 plus 1, or you can write R2 plus R3 by R2, right? But we have to find out the value of I3 by I1. That means we can reverse this. So I3 by I1 will become equal to R2 by R2 plus R3. Okay. Therefore, out of the given options, which one will be correct? Option B, right? Now let's come to question number 43. It is from the chapter Moving Charges and Magnetism. And here in the given product vector F equals to Q vector V cross vector B, we have to find the complete expression for vector B when the value of Q, vector V and vector F are already given. Okay. So according to this question, vector F equals to Q vector V cross vector B. The value of vector F is given as 4 I cap minus 20 j cap plus 12 k cap, right? And the value of Q is given as 1. And then we have to perform the cross multiplication of vector V cross vector B. So how do we do this? We write the I cap, j cap and k cap here. Then we put the values of I component, j component and k component of respective quantities. So first we write the components of velocity, vector V. So what is the I component? It is 2 here, okay? Similarly, the j component is 4 and the k component is 6. And for B, the I component is B, j component is also B and k component is B naught. Okay. So here when we perform the cross multiplication, we get 4B naught minus 6B as the I component. Okay. So this is the I component here. And the j component is minus 2B naught plus 6B j cap. Okay. And what is the k component? It is 2B minus 4B k cap. Okay. So now we will compare the left hand side and the right hand side. Okay. So on the left hand side, the I component is given as 4. That means 4 will be equal to this one, the I component on the right hand side. So it will be equal to 4B naught minus 6B. Similarly, the B component, that is minus 20, will be equal to the B component this side. That means minus 2B naught plus 6B, and the K component 12 will be equal to K component here, that is 2B minus 4B. Okay. Now if we solve it, suppose you solve this third part, then you will get the value of B as minus 6, right? So this is the B. Then we can put the value of B in other equations to find out the value of B naught. So on solving, we'll get the value of B as minus 6 and B naught as minus 8. Then what will be the complete expression for vector B? Vector B will become equal to minus 6 I cap minus 6 j cap minus 8 k cap. Why? We put these values of B and B naught in this equation. Okay. So we get this. So out of the given options, which one is correct? It is option B, right? So this is the correct answer here. Question number 44 is from the chapter Gravitation, and the question is, a particle of mass small m is projected with a velocity v equals to k into escape velocity from the surface of the earth, and k is less than 1. Then the maximum height above the surface reached by the particle is, okay. So here we have to remember that from conservation of mechanical energy, the total energy will remain conserved. And what is total energy? It is the sum of kinetic energy and potential energy. So the total energy before reaching the highest point will be equal to kinetic energy, that means half mv square, plus potential energy, and the formula for gravitational potential energy is minus g into small m into capital M by r, where g is the gravitational constant, small m is the mass of the particle, and capital M is the mass of the earth, whereas r is the radius of the earth. So that will be equal to the total energy at the highest point. And what will happen at highest point? The particle will stop moving for a while, right? So their kinetic energy becomes zero. Only potential energy exists. So using the same formula for potential energy, we write minus g small m into capital M by r plus h, where because height is also included here. Okay. So now small m will be cancelled because it is on both sides. So we can simply write v square by 2 minus g capital M by r equals to minus g capital M by r plus h. Now we can bring this part to the right side and we'll get v square by 2 equals to g into m by r minus g into m by r plus h. So that will be equal to g into m, and here 1 by r minus 1 by r plus h. That means v square by 2 will be equal to, here if we solve this thing, we'll get g into m, and here h by r plus h. Okay. Now it is also given that v equals to k into escape velocity. Okay. So if v equals to k into escape velocity, that means v square equals to k square into square of escape velocity. Okay, so we can put this value here. So v square will be equal to k square into escape velocity square divided by 2, and that is equal to this thing. Okay, that means gm into h by r plus h. Okay. Also, we know the formula of escape velocity. What is the formula for escape velocity? It is equal to root under 2 into g into m by r. So what will be the square of escape velocity? The square of this, that means 2gm by r, root will be removed. Okay. So let's put this value. Here we'll get half k square, and in place of escape velocity square, we can write 2gm by r, and this side we have gm into h by r plus h, right? So gm is on both sides, cancelled, half cancelled with this 2, r is also cancelled on both sides. So what is left now? Here we are left with k square on the left side and h divided by r plus h on right hand side. So if we solve this, we'll get rk square plus hk square equals to h. Okay, that means rk square equals to h minus hk square, that is equal to h 1 minus k square. Okay, so what will be h? H will be equal to rk square divided by 1 minus k square. Okay, so can you find this in the given options? Rk square divided by 1 minus k square. It is option D, right? The same thing has come. So this is the correct answer here. Question number 45 is from the chapter Electrostatic Potential and Capacitance, and the question is 27 drops of same size are charged at 220 volt each. They combine to form a bigger drop. Then calculate the potential of the bigger drop. So first of all, if several small drops combine to form a bigger drop, then which quantity will remain unchanged? The total volume, right? So the total volume remains same, but the radius will vary. Okay, so suppose the radius of each small ball is small r, and here the radius will be same for all the small drops because they are of same size, right? And suppose the radius of the bigger drop is capital R. Okay, it will be bigger, so the radius will be more. So what will be the volume of the bigger drop? It will be equal to 4 by 3 pi capital R cube, and that will be equal to the total volume of the small drops. That means 27 times the volume of each small drop. So that will be equal to 27 into 4 by 3 pi small r cube. Okay. Now 4 by 3 is on both sides, so it will be cancelled. Pi is on both sides, so it will be cancelled. What is left? Capital R cube equals to 27 into small r cube. Okay. Now if we find out the cube root, we will get capital R is equal to 3 into small r. That means the radius of the bigger drop is 3 times the radius of the small drop. Okay. Now, potential. What is the formula for potential? It is given as K into Q by R, where Q is the charge and R is the radius, right? So suppose we find out, I'm writing P for potential here because if I write V, it will be confusion. So P1 by P2 will be equal to Q1 by Q2. Okay, because the potential is directly proportional to Q, and the it will be multiplied with R2 by R1 because the potential is inversely proportional to R, right? Now, here P1 is the potential of small drop. Okay, so that is given as 220 volt, and the potential of bigger drop is unknown, and that is equal to Q1, that means charge on each small drop, so that is equal to Q here, and the total charge on the bigger drop will be 27 times Q, okay, into radius of the bigger drop here, okay, R2. So that is equal to 3 times the radius of the smaller drop, and here smaller drop has radius smaller. Okay, now if we solve it, we'll get 220 divided by P2 equals to 1 by 9. Okay, because QQ cancelled, RR cancelled, and 3 into 9 is 27. Okay, so 1 by 9 here. That means P2 will be equal to 220 into 9, and that is equal to 1980 volt. Okay, so out of the given options, option D will be the correct answer here. Question number 46 is from the chapter Alternating Current, and the question is, a series LCR circuit containing 5 Henry inductor, 80 microfarad capacitor and 40 ohm resistor is connected to a 230 volt variable frequency AC source. The angular frequencies of the source at which power transferred to the circuit is half the power at the resonant angular frequency are likely to be. Okay, so here we should understand first that there are two types of frequencies. First one is the resonant angular frequency, that is written as omega naught, and the second one is the half power frequencies that are written as omega 1 and omega 2. So there are two half power frequencies. And what are half power frequencies? These are the frequencies at which the power transfer to the circuit is half the power at resonant angular frequency. That means if the power at this frequency omega naught is P, then the power at half power frequencies will be P by 2. Got it? So we have to determine omega 1 and omega 2 according to this question. So first of all, we'll find omega naught, that is resonant frequency, and it is given as omega naught equals to 1 by root under L into C, where L is the inductance and C is the capacitance. So here the value of inductance is 5 Henry. Okay, so it is 5 into 80 microfarad, that means 80 into 10 to the power minus 6 farad. Okay, now if we solve this, we'll get 50, and the unit for omega naught will be radian per second. Okay, now we can find out omega 1 and omega 2 using this formula. So the formula for half power frequency is omega naught plus minus R by 2L, where R is the resistance and L is the inductance. Okay, So here we know that there are two half power frequencies. First one is omega 1 and second one is omega 2. So for omega 1 we'll write omega naught plus r by 2l, and omega 2 will be omega naught minus r by 2l. Okay. So let's put these values. Omega naught is 50 radian per second. So 50 plus, here we'll write R is 40 ohm. So 40 by 2 into inductance. So inductance is 5. So 2 into inductance is 10. That means this is 4. Okay. So 50 plus 4 will be 54. And here it will be 50 minus 4. So it will be equal to 46, right? And the units will be radian per second. So the correct answer will be option C, that is 46 radian per second and 54 radian per second, right? Alright, now question number 47 is from the chapter Magnetism and Matter. And the question is, a uniform conducting wire of length 12A and resistance capital R is wound up as a current carrying coil in the shape of first an equilateral triangle of side A and second a square of side A. Okay, so the magnetic dipole moments of the coil in each case respectively are. So here, first of all, a uniform conducting wire has been taken whose length is 12A, right? And resistance is R. Then it has been wound up as a current carrying coil. So coil has several turns. So first of all, it is wound in the form of an equilateral triangle of side A. So the total length of the triangle is what? It is A plus A plus A, that means 3A. Whereas the length of wire is 12A. Then how many number of turns would be required to make this triangle? It will be 12A divided by 3A, that means 4 turns. Okay. So number of turns for this equilateral triangle will be 4. Similarly for square, the length of the square is 4A. Okay. A plus A plus A plus A, it is 4A. Whereas length of wire is 12A. Therefore, the number of turns would be 12A divided by 4A. Okay, so it will come out to be 3 turns, right? So here the number of turns will be 3. Now, we can easily find out the magnetic moments of coil in each case. Okay, for the first one, we know that the formula for magnetic moment is N into I into A, where N is the number of turns, I is the current, and A is the area. Okay, so number of turns for the equilateral triangle is 4, current is I, and area for equilateral triangle is root 3 by 4 A square, right? This is the formula for area of equilateral triangle, where A is the side of triangle. So here if we solve this, we'll get root 3 I A square, right? Similarly for square, it will be NIA, and here N is equal to 3. So 3 into I into area of the square is A square, right? That means side square. So here we'll get 3IA square. So the area of triangle is root 3IA square, and the area, magnetic moment of the triangle is root 3IA square, whereas the magnetic moment of the square is 3IA square. So in option 1, a root is missing here, so it will be the correct option. Okay. Okay, now question number 48 is from the chapter Systems of Particles and Rotational Motion. And the question is, from a circular ring of mass capital M and radius capital R, an arc corresponding to a 90-degree sector is removed. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring and perpendicular to the plane of the ring is k times mr square. Then the value of k is. Okay, so let's first understand what is mentioned in the question. We have a ring whose mass is capital M, right? And its radius is capital R. Then an arc corresponding 90 degree has been removed. So if this is 90 degree, then this portion has been removed. Okay, so the total angle is 360 degree, right? And 90 degree has been removed. That means 1/4 has been removed. So initial mass is m, and mass removed will be same as the portion that is removed. So 1/4 is removed. So m by 4 is removed. What is the remaining mass then? Remaining mass will be initial mass, that is m, minus mass that has been removed, that is m by 4. So here we'll get 3 by 4 m. So this is the remaining mass. Now what is the formula for moment of inertia? It is given by the formula mr square, where m is the mass and r is the perpendicular distance with the axis of rotation. So in this case, axis of rotation is passing through the center. So this perpendicular distance will be same as the radius. Okay. So inertia, moment of inertia of this thing will be mr square. Whereas for the remaining part, suppose this is the remaining part, then here the moment of inertia will be mass into perpendicular distance square, and here mass is 3 by 4m, right? And this perpendicular distance will remain same, that is radius. Okay, so it will be equal to 3 by 4 mr square. Okay, and according to the question, it is equal to k times mr square, isn't it? So if you compare these two, then we can understand that k is equal to 3 by 4, right? So option A will be the correct answer here. Now question number 49 is from the chapter Electromagnetic Induction, and the question is, two conducting circular loops of radii r1 and r2 are placed in the same plane with their centers coinciding. If r1 is greater than r2, then the mutual inductance M between them will be directly proportional to. Okay, so here we have two loops whose centers are coinciding. That means they will have a common center, right? And it is given that R1 is greater than R2. That means the outer ring or the bigger loop will have the radius R1, whereas the inner loop will have the radius R2. Okay. Now suppose that the current in the outer loop is I, then what will be the magnetic field at the center? Magnetic field at the center is given by the formula mu naught I by 2R1. Okay. So now using this magnetic field, we can find out the magnetic flux through the inner coil. Okay. What is the formula for magnetic flux? It is equal to the product of magnetic field and current, right? So magnetic flux through the inner coil will be equal to B into A, where B is the magnetic field and A is the area of the coil. So magnetic field is mu naught I by 2R1 at the center, and area of the inner coil is pi r2 square, because radius of inner coil is r2. Okay, so we can write it like this: mu naught I pi by 2, and here r2 square by r1. Okay, now as per the definition, magnetic flux is equal to mutual inductance into current. That means this is also the magnetic flux and this is also the magnetic flux. So both are same. Okay. That means M into I is equal to mu naught I pi by 2 into R2 square by R1. So here I will be cancelled. So what is the value of M? It is equal to mu naught by 2 pi r2 square by r1. That means m is proportional, directly proportional to r2 square by r1. Okay. So here it is asked in the question, the mutual inductance between them will be directly proportional to, and here we will have this option D as the correct answer. Okay. And now the last question is from the chapter Motion in a Plane, and the question is, a particle moving in a circle of radius capital R with a uniform speed takes a time t to complete one revolution. If this particle were projected with the same speed at an angle theta to the horizontal, the maximum height attained by it equals to 4r. Okay, then the angle of projection theta is given by. Okay, so suppose this is the circular path of the particle with radius capital R. Then what will be the distance covered in one revolution? It will be equal to the perimeter of the circle, that means 2 pi R. Okay, and the time taken is given as capital T. So what will be the speed of the particle? Speed u will be equal to distance by time, that means 2 pi r by t. Okay, so we'll take it as equation 1. Now it is given that the particle is projected with the same speed at an angle theta to the horizontal. That means the particle is in projectile motion, right? And we know that in case of projectile motion, the maximum height is given by the formula u square sine square theta by 2g, right? So this is an important formula that we have to remember. Now we can put the value of equation 1 in equation 2. Okay, u is equal to 2 pi r by t. So what will be u square? U square will become 4 pi square r square by t square and into sine square theta by 2g. Okay, so 2 into 2 is 4 and it will be equal to 2 pi square r square sine square theta by t square g, right? Now according to the question, this maximum height is equal to 4r. R is the range, okay? So it is equal to 4r. So here we can find out the value of sine square theta by dividing 4r by the remaining part of this expression. Okay, so sine square theta equals to 4r divided by 2 pi square r square into t square g. So here 2 into 2 is 4 and 1 r will be cancelled here. So it will be 2 t square g by pi square r, right? So this is the value of sine square theta. What will be sine theta? It will be the root of this, okay? Or we can write 2t square g by pi square r to the power half. That means root of this, okay? So value of theta will be sine inverse of this expression. So sine inverse of 2gt square by pi square r, okay, to the power half. Which of the given options match with this? Option D, right? So option D will be the correct answer.